Hey, sports fans, back again with, as promised, part two of uh, GEMS, final exam GEMS. I apologize in advance, the sound isn't the best because I was recording it on my iPad in my classroom yesterday. So I was at a baseball game, high school baseball game, so I'm just now recording the intro and outros. So I hope you like it. Okay, like I said, welcome back. If we're just meeting, my name is Mark Noldy. I've been teaching high school math for over 20 years now, almost 25 years now. So here's one of my first gems that would be likely to be seen on a final exam. So let's have at it. It says, closed to tourists since 1990. The Leaning Tower of Pisa in Italy leans at an angle of 84.7 degrees. The figure shown shows that 171 feet from the base of the tower, the angle of elevation to the top is 50 degrees, so right here. Find the distance to the nearest tenth of a foot from the base of the tower. So in looking at this, what I see is angle, side, angle. So angle, side, angle tells me I will be using angle. Let me draw in red, say angle, side, angle. That tells us that we need to use the law of sines. Law of sines. The other time when we use the law of sines also is, remember, SSA. But this is an ambiguous triangle, and it could be that there's no triangle, one triangle, or two triangles. But that's not the case here. So first thing I would like to do is go ahead and find this angle here. So this angle, I can add up the 50 degrees and the 84.7, subtract those from 180 because a triangle has 180 degrees in it. So this would make this a 45.3, but it's a pretty bad 45.3 degree angle. So now I can set this up. So we'll set it up like this. 171 feet divided by the sine of 45 degrees equals what I'm looking for, this value here, be, over the sine of 50 degrees. So when we solve this for b, we end up looking at b equals, let's see, 171 times sine 50 degrees divided by sine 45.3 degrees. I actually forgot my 0.3 up here. All right, so this is just type it into the calculator, and usually, rounding these to one decimal works out fine. So when I do this in the calculator, we come up with 184.3 feet. So that the Leaning Tower of Pisa is 184.3 feet tall. So that is a classic example that you would be likely to see on a final exam. So here's a second example. Final exam gems. So two tugboats that are 120 feet apart pull a barge. So these two tugboats are pulling this barge. If the length of one cable is 212 feet, which is listed here, and the length of the other is 230 feet, find the angle formed by the two cables. And they're telling us also that they are 120 feet apart. So I see, what do I see? I see side, side, side. So that tells me use the law of cosines. So we're going to have to solve it for this angle right here. So that's the angle. I should draw that in red so it looks. So that's the angle we're looking for. So let's call this, I don't know, triangle A, B, C. right? Just to label it. That would make this side A, this side B, and this side C. So one of the formulas is a squared equals b squared plus c squared minus 2bc times the cosine of a. So this angle right here is always going to match this. So a, capital A, lowercase a. So I usually prefer to go ahead and solve this for the cosine of a because that's the angle I'm looking for. So I'm going to move some stuff around. I'm going to move 2bc cosine a to the left-hand side, and then I'm going to move a squared to the right-hand side. So that looks like this. And then I'm just going to divide both sides by 2bc. So cosine a ends up being b squared plus c squared minus a squared divided by 2bc. So now it's like the last example. Now that we have some values here, we can go ahead and start to substitute. So let's see. My b, that was 212. So 212 squared. Guess I'll put some parentheses around that. Plus the other side, c, which is 230 squared, minus a squared, that's 120 squared. Divide that all by 2 times b times c. So this could be, punched into a calculator with not too much challenge here. I did the top and bottom separately. So the top, if I type this into a calculator, comes out to be 83,444. And my denominator was 97,520. So this is what cosine A is equal to. So I got a little extra fraction bar here. Let me get rid of that. So A is going to be the inverse cosine of that crazy angle, or that crazy ratio. I divided that out, and I got 0.85. Get that back. 856603774. Now, if you're just writing this down, you don't have to write all these decimals out right here that I wrote out. These are in the calculator. So when you do divide this, you're going to just hit inverse cosine of the answer, right? So in your calculator, it looks like this. Cosine inverse, and you just chose answer, whatever that answer was. And that gave us, if I round this to the nearest tenth, it was 31.2 degrees. It was a long decimal also, this. There's more stuff to that decimal. But 31.2 degrees, I think, is pretty solid for this problem. So there you go. A second final exam gem that is uses the law of cosines because it had a side and a side and a side. Another good example for a final exam problem. This uses the same law as the first one. Let's read it and see what it has to say. A satellite orbiting the Earth passes directly overhead at observation stations in Phoenix and Los Angeles. Those are 340 miles apart. At an instant when the satellite is between these two stations, its angle of elevation is simultaneously observed to be 60 degrees in Phoenix and 75 degrees in Los Angeles. How far is the satellite from Los Angeles? So we want to know this side right here. So it's angle, side, angle. So that is going to mean I'm using the law of sines. So I need to figure out this angle here that is opposite from this side here. So angle C and side C. So take your 180, and we could figure that out easily. I don't even have to write this down probably for most of you, but minus 75 degrees, minus 60 degrees, that gives us 45 degrees. So this is a 45 degree angle here. So let's go ahead and use the law of sines now. I know the distance, 340. That's the distance here between Phoenix and Los Angeles. The angle opposite is a 45-degree angle. So 340 divided by sine 45. That's going to equal sine 60 degrees. Whoops, I wrote that upside down there, didn't I? Let me erase that. So I'm trying to find B, and that is opposite the sine of 60. So I have the sides on the top and the angles on the bottom. So I had accidentally copied this up here. So go ahead and cross multiply to solve for B. We find out that B is equal to 340 times sine 60 degrees divided by sine 45 degrees. So when we type this in the calculator, pretty easy to get an answer. I'm coming up with, it's approximately, I guess I should technically use an approximately sign here. So approximately 416.4 miles. So that's how far above or how far from Los Angeles this satellite is. So assuming, of course, the Earth is flat, because the Earth is rounded, right? So this is going to be not exactly right. So, but that's besides the point. So this is for precalculus, another gem. Okay, so we have not seen this one yet. So let's read it and see what it says. A boy is flying two kites at the same time. He has a 380-foot line out on one of them and 420 feet on the other. And he estimates the angle between them to be 30 degrees. So we want to approximate the distance between the two kites. So we haven't seen this one yet. But what I'm going to do is just draw a little line here. So that makes a triangle. And we have side, angle, side. So what I'm going to do is remember that side, angle, side tells me it's the law of cosines that we use here. It's the law of cosines. All right, so let's go ahead and I'll write down the formula. But first, we should probably label this triangle. Just arbitrary here, A, B, C, which would make the side I'm looking for lowercase a. This would be, lowercase c. And this one is lowercase b. So let's go ahead and write our formula. A squared equals b squared plus c squared minus 2bc times the cosine of a. So same formula as before, but this time I don't have to rearrange it all because I'm solving for a. So I'm just going to go and substitute straight in here. So it goes like this. A squared equals b squared. That'd be 380 squared plus 420 squared minus 2bc cosine of, he thinks that's 30 degrees. So we just fill that in. And I just instruct students, use your calculator to put this in here. You're going to come up with 44364, and there's some decimal to it, 0.6911. And then just in your calculator, take the square root of this number here. And the square root of that number is approximately 210.6 feet. A lot of times what I have students do is take their answer that's in the calculator and then hit the caret key, raise it to the 0.5 power, because that's like taking the square root, something raised to the 1/2. So that's kind of a quick shortcut for that. So in any event, these kites are 210.6 feet apart. All right, so number 5, I saved the best for last. This one requires several steps to do it. We're looking at, I guess, the CN Tower in Toronto. It's the tallest freestanding structure in North America. A woman on the observation deck up at the top, it's 1,150 feet from the ground, wants to determine the distance between two landmarks, so this landmark and this landmark, on the ground below. She observes that the angle formed by the lines of sight to these two landmarks is 43 degrees. She also observes the angle between the vertical line of sight to one of the landmarks is, 62 degrees. So that's this red one. And the other one is 54 degrees. So this angle here is 54 degrees. So we want to find the distance between these two landmarks. So we have to first find this blue line and this red line. All right, so let's zoom in on that. So there's going to be like another, leg to a triangle here. So here's how I sorted this one out. We took this one and decided to break it into 3 parts. So I know that this is 1,150 feet high here. So I'll start with the triangle on the back first. So let's see, 150 feet, 1,150 feet, sorry. And there's a distance here that I guess we don't know. But we do know, let's see, I'm going to color coordinate here, that this angle is 40, nope, not 43, I'm looking at the picture wrong, is 62 degrees. Then there's another triangle. I'm going to open these up. So this is also 1,150 feet high, but this triangle has a little bit of a shorter angle. Oops, I want to color coordinate that. So this angle is a little smaller, this blue one. So that would come down to here. So I'm going to write 54 degrees here. And of course, I'm going to say they built this building at a right angle to the ground. And I can find the other angles as well right now. So why don't I go ahead and do that? So when I subtract 62 and 90 from 180, find out that this is 28 degrees. So I have a 62, a 28, and then over here on the triangle with the one blue side, we figure out that this is 36 degrees. So got a couple of things that we need in order to find this blue side and this red side. Because once we do that, we can have the red side, which is here. This is like the front of the picture. And then this is the distance between the two landmarks. This is the ultimate question. This is the ultimate question mark right here. So we'll put a big fat one there. So let's go ahead and, well, I want to first put the right color here. So this was blue. That's this blue side up here. Let me use my pointer. So this blue side is this blue side in the picture. This blue side is the same as this blue side. And this red side is the same as this red side. So I have to first figure out these two sides. Is there any other information? Oh, yes, 43 degrees. So this angle is, let me undo that. This angle is 43 degrees. Okay, so let's go ahead and figure this out. So for the red triangle, let's see here. I'm calling it the red triangle, but it has that one red side. I'd have the sine of 28 degrees over 1150 is equal to, well, the sine of 90 degrees, because this is a 90-degree angle and it's opposite the side I want to know. So I'll just leave that as red question mark. So cross multiply, red question mark is 1150. Sine of 90. Sine of 90 is 1, so this makes for easy math. Divided by the sine of 28. So still type all of this into the calculator, and you'll come up with about, let's see, I came up with about 2449.6 feet. So this is 2449.6. making this 2449.6. Now let's do the other triangle over here. So that is blue. So that would give me, I guess, sine of 36 over 1150. That's the height of the tower, equals the sine of 90 divided by the blue question mark. So when I cross multiply, blue question mark is 1150 sine 90 degrees divided by sine 36 degrees. And just type that into your calculator. And go ahead and rewind this as many times as you need to, because I am just sort of copying off my answer key. So now I know that this side is 1956.5. Now, of course, the full decimals would be in your calculator, but I'm thinking this is good enough for government work here. So this, my big question mark, like that artwork, squared equals the other two sides squared. I'm using the law of cosines here again. So this number squared plus the other side, 1956.5 squared, minus twice their product, 2449.6 and 1956.5 times the cosine of 43 degrees, because it said the woman standing at the top of the tower either estimated it or said that it was 43 degrees. All right, so type this into your calculator. You get big question mark squared is, and this is a long decimal, but you don't have to write the whole thing down. Like I've been saying, the calculator holds on to these decimals for us. So when I take the square root of both sides, we get that this is about, I should use my squiggly equals, is about 1,678.7 feet. So I'm going to shrink that out again. So the distance between these two buildings right here and right here is figured out or calculated to be 1678.7. And there you have it, my friends. 5 awesome gems that could very likely be problems similar to these anyway on a final exam. So let me know in the comments down below what you thought of these. All right, so those are some pretty awesome problems. I hope you liked them. I kind of worked through them. I had an answer key that I was kind of going off because this video is getting kind of long, so I didn't want to go too long. I think this will be my first 30-minute video. But in any event, question of the day, if you didn't answer it last time, what is the hardest final exam that you've ever taken? Write it down in the comments down below. And if you don't mind, give this a thumbs up.